So here we are back again to talk about Keras 2C. That's a library you use to export the Keras models to C, C++ language. So we are going to deal with this section in our article. So here is the reference to Keras 2C, this article here. It's a library for converting Keras neural network to real-time compatible C. So this is the article referenced by our paper. And let's go. I will show you. But before that, let's remember that the best models after our model evaluation process, the best models are MLP23, or that is MLP SAND and RTT, and MLP with the three features, AC, SAND, and RTT. So we are going to export these models to C language using Keras 2C. Okay. First, we are going to show how we test. Let me show you one file here. This file here. This file here is generated. Was generated during the training process. Okay, so here we have a vector, an input vector, and the output of the Keras model. In this case, we have the model using MLP architecture, using AC, SAND, and RTT. So we have three dimension vectors, input vectors here, and we have the output, the response, the model response, corresponding with one of these entrance, these inputs here. We are going to use these files to test the Keras 2C codes corresponding to this model. I will show you how we are going to transfer a sample of these vectors and corresponding output to C++ project. I mean, check if Keras 2C code corresponding to Keras model outputs values close to this one here for each input. I will show you how you can do that. So I will generate another file. This is a file generated during the training. So this sample here is taken from the training set. Let's take one file of the generalization process. So let me collapse this here. Oops, let me collapse this here. Okay, here, let me collapse this here. So you remember that we performed some generalization tests. So let's get a sample of features and corresponding response, corresponding outputs for one of this generalization process here. We can choose one of them. We are going to use the MLP accent and RTT. We can do that, for instance, for cubic chant flows. So here we have cubic chant flows. We have already renamed the files. Let's go to the MLP accent and RTT. Let's execute again the generalization test for this scenario. Okay, so here we have the results. As you can see here, we have a file generator that's a sample of vectors composed by these features here, X and the corresponding response. We can see that here. So let's wait a little. It's loading the file. So here we have the inputs and the output of the neural network corresponding to MLP accent and RTT for this scenario with 20 cubic flows. So let's copy this file here to our tests folder. Let's go to this one here. Here we have. Let's go to the selected, this one here. Here we have the file generated during the training process. Let's add this one here, generalization. So here we can see this file here. Here we have. Let's visualize it. So here we have the file. So we are going to take some lines of each one of these files, the files generated during training process, the file generated during generalization test for 20 cubic flows. Remember, we are here. Okay, we are here with these flows cubic 20 for 100 Mbps. That's the bottleneck we are working here for 100 Mbps. Okay, for 100 Mbps. Okay, so we are going to transfer. I will show you. We have to make some modifications because the C++ syntax is a little different. We are going to construct C++ or C vectors, but with search and replace, we can easily get come from this format here to the C++ array initialization format. So before we are going to our tests, let me show you the other side a little bit about our CPP project, where we are going to test our Keras-2C exported model. Okay, let me show you. I will show you this project here. Here we have initializations, okay, and here we have the abstract class, and here we are the real object that is an NLP model that implements the Keras the Keras model from the Keras2C code. Okay, we are talking about this section, this part of our article, of our paper. So here we have the abstract class, the concrete class here, abstract class here, concrete class here, and the method here we have some Keras2C tensor initialization. The method that do the hard work is this one here, where we input this tensor and get the output in this tensor here. We have a loop, so in this loop we are going through each one of these values here. I'll show you how we transfer. And in this loop, we test the difference between the Keras prevision and the Keras2C output. And if it's bigger than 10 powered to minus 4, we stop the execution to analyze that. Okay, so this is how we are going to test. I will show you in the sequence how we transfer. It's important before that. It's important to say that this is the method that I have said that do the hard work. We can see this method here. Okay, so we are going to copy the code, the corresponding code from the files we generated in our column. Here you can see it. Let's show you. Okay, here we have this function that will be a method in our project, and we are going to test. Okay, I will show it in the sequence.